Hello and Assalamualaikum. I'm Atika Liana. I will be representing my fellow teammates Dr. Nalila Isa, Dr. Mazida Tajuddin and Dr. Nurhani Kaswan. We are from the discipline of Systems School of Electrical Engineering, College of Engineering, University Technology Mara, Shah Alam, Selangor, Malaysia. Our project is entitled ARX Modeling and FPID with Model Reference Controller Design of a Hot Air Blower System. The heating system is the most significant aspect of thermal technology, and numerous methods to control it have been proposed for the past years. And in the past years, proportional integral derivative PID controller is the most common controller used in a slow and nonlinear process such as temperature control. The ability to control temperature is crucial in order to keep the quality of the product under control, hence minimizing any possible major losses. One of the reasons why the PID controller is commonly used is that because the controller itself is reliable in a wide range of operating circumstances and it is easy to use. Due to nonlinearity, disturbances, variability, and modifications in objective architecture, the system was unable to achieve a satisfactory outcome using the previously specified PID parameter. However, fuzzy control has recently been more popular than traditional PID control since it simply represents the implementation of human control strategy, whereas PID control is based on mathematical formulation. Most of heating plants are complex with higher order systems, which leads to unsatisfactory performance. The problem with PID implementation is achieving the best possible combination of controller gain. Practically, in order to achieve a desirable transient response, traditionally designed PID controller often use trial and error technique of tuning the parameter of the controller. However, drawbacks of this system is that it can become a tiresome task, causing a decrease in transient response when the set point is altered. The system to be controlled was nonlinear and has significantly time delay as observed. This work was conducted due to this problem. The control objective is to maintain the process temperature at a given value. Next, we will go to objective. The objectives of this research are: first, to design an FPID controller with model reference for a hot air blower system to improve the transient response performance of the system. 2. To evaluate and compare the performance of the proposed controller and FPID controller. Limitations of the study are as follows. The study is for low temperature heating system applications such as laboratory equipment, for example PT326 process strainer, incubators, and oven. Next, the temperature is set to 40 degrees Celsius, and this research is limited to ARX 223 model only. The controller design simulations is developed using MATLAB simulating environment. Next is methodology. The PT326 process strainer is chosen as a heating model system that must be kept at a temperature of 40 degrees Celsius. Model of the system is adapted from K. Osman's previous work. ARX 223 were chosen for this study as the three conditions of the model validation criterion are met. The three conditions are the best fits reading, the smallest loss function, and lowest Akaikis final prediction error. Here the model of the system can be seen in the figure on the right side, which is on equation 2 and 3. Also, the designing of the proposed controller is done using MATLAB simulating environment. Next, design and analysis of FPID controller. FPID controller evolved from conventional PID controller. It is a combination between PID controller and fuzzy control. The fuzzy relationship between three PID parameters Kp, Ki, and Kd and the error and error change rate can be determined using fuzzy control theory. When the PID parameters are modified with fuzzy logic, the traditional PID controller transforms into an FPID controller. Fuzzy membership rules were constructed as shown in Table 2, which consists of 7 different variables. As we can see, the linguistic variables employed were negative big, negative medium, negative small, 0, positive small, positive medium, and positive big. Since the variables were all set to 7, the matrix is 7 by 7. As a result, the system made use of 49 fuzzy rules. For the FPID and PID Simulink model, PID parameters were modified for each polynomial model using MATLAB Simulink PID Tuning Extension Toolbox. Design and analysis of FPID controller with model reference. To specify the desired output of the system, this research proposes a reference model. The reference model is constructed in accordance with the intended transient specification. The model reference evaluated in the study is shown in equation 12 and 13, which is a first-order transfer function in discrete form and continuous form with sample time of 0.1 seconds respectively. Figure 12 represents the block diagram of the heating system's FPID with model reference controller in MATLAB Simulink environment. A desired temperature of 40 degrees Celsius is designed for the heating system. The purpose of this effort is to develop suitable controls capable of tracking or following the set point, which is the desired temperature. Okay, this is the results. According to the simulation results, the FPID controller with model reference response produces a better outcome than the FPID controller, as we can see from figure 14a. Next, figure 15a shows the simulated error response graph of both controllers. It can be observed that both controllers move closer to 0 as the time increases. It can be observed in Table 5 that there are differences in output response results for both controllers. In terms of rise and settling time, FPID controller with model reference are 8.09 seconds and 11.74 seconds faster than FPID controller. Both responses show no overshoot with low RMSE value and both responses are stable. The simulation is analyzed using the control system output response in terms of settling time, rise time, overshoot percentage, and root mean square RMSE. In conclusion, the objective of this study is to compare FPID controllers with and without model reference on a hot air blower system. In this study, specifically on the PT326 process trainer, the simulation results indicates that the reaction time and settling time of the FPID controller with model reference are better than those of the FPID controller. Additionally, it demonstrates that a system controlled by an FPID controller with a model reference is capable of controlling the desired temperature specified by the model reference. That's all. Thank you.